students, my name is Dr. Salahuddin, working as Associate Professor in Noida Institute of Engineering and Technology Pharmacy Institute. Today, I will discuss about the general anesthetics part 1. So, general anesthetics, that this general anesthetics that we are using not in a single drug, but it is used in the combination with the other drugs. Now, the question here, why we are using this general anesthetics? The basic purpose of this using the general anesthetics in operational procedure. So, under the general anesthetics, the patient do not feel pain. So, they do not feel the pain because it produces analgesia and the loss of consciousness and the relaxation of the muscles also. So, see, general anesthetics is used basically in the combination of the intravenous drugs and the inhaled gases. So, here the general anesthetics basically there are two types of the general anesthetics, that is the inhalational anesthetics and the intravenous anesthetics. So, here by using this general anesthetics, the patient can be thought as of being as a controlled the reversible loss of consciousness. This is a very important point. This is controlled loss of consciousness. Okay. So, the general anesthetics which depresses the central nervous system and it produces that is the loss of consciousness, means when it will depresses the central nervous system, because these drugs act on the central nervous system and it depresses, because it will cross the blood brain barrier easily, because it is a lipophilic in nature. Okay. Now, here the general anesthetics, the definition of this general anesthetic says, what it says that the anesthesia, it is divided into the two words. First is the and means without and the loss of consciousness. Okay. So, here the sensation, the without the sensation means anesthesia means without the sensation. So, the drug here which produce the reversible loss of consciousness and the reversible loss of sensation also. So, here the purpose includes the general anesthetics, that is the unconsciousness, that is the loss of awareness, the patient feel the unconsciousness, and the analgesia, that is the loss of pain. Next is amnesia, the loss of memory. Fourth one is immobility, that is the loss of motor reflexes. The fifth point is the paralysis, that is the skeletal muscle relaxation and the normal muscle relaxation. Now, what are the features of this general anesthetics? The ideal features of this general anesthetics, the first feature of this general anesthetic is loss of consciousness, especially pain. Now, it produces the sleep in unconsciousness state and the amnesia, loss of memory. The third one is the third feature, that is the abolition of somatic and autonomic reflexes, and the third is the important point, that is immobility, and muscle relaxation. Now, further I will discuss about what are the different stages of anesthesia. In the stages of the anesthesia, that we can divide into 4 part, that is 1 to 4, 4 stages, and these 4 stages it is divided into, that is first stage, that is analgesia, second stage, stage of delirium, the third stage that we have to discuss, that is the surgical anesthesia, here the third stage, and the stage 4 that it covers the medullary paralysis, that I will discuss one by one. What are the different stages, that is the analgesia. So, there are some points that we have to discuss in analgesia, that is the loss of consciousness and the patient feel a dream like state. So, when the patient dream like state and the reflection and the respirations remain normal. Now, the second stage is stage of delirium. In the stage of delirium, it starts from the loss of consciousness. The loss of consciousness was the stage of the analgesia. So, it will start from the loss of consciousness to the beginning of the irregular respiration by the patient. And here the apparent excitement is seen by the patient when we are using this general anesthetics. In a stage 2 also the muscle tone increases, it increases muscle tone, the jaws are tightly closed and the heart rate and the blood pressure may increases. So, after the stage 2, the stage 3 start. So, it extends from the onset of irregular respiration, because this stage 2 ends the irregular respiration. So, here it starts from the irregular respiration to the cessation of the spontaneous breathing, and again it is divided into the 4 plane, plane 1, plane 2, plane 3 and plane 4. So, these are planes when it can be divided into the first plane is when the eyes becomes fixed. The second one is loss of corneal and the laryngeal reflexes. The third, the pupil of the eye start dilating and the light reflexes. Dilated pupil decreases muscle tone, BP may falls. Now, the fourth one is medullary paralysis. In this stage of the anesthesia, in this stage respiratory and the vasomotor control ceases. Now, here what are the basic differences between the general anesthetics and the local anesthetics, because we are using, there are 2 types of anesthetics, general anesthetics and the local anesthetics. So, here the first difference in the site of action. So, the site of action of the general anesthetics in central nervous system and the site of action of the local anesthetics is a peripheral nervous system. Area of the body involved. The second point is very important point, and the area of the body involved, in the general anesthetics it involves the whole body, and in the local anesthetics it will restricted in the local area. So, that is why we are calling as the local anesthetics. Here the consciousness, what is the effect of the consciousness by the general anesthetics and the local anesthetics. So, here the central nervous system general anesthetics lost the consciousness, that means loss of consciousness, and here there is a no unaltered loss of consciousness. Patient become conscious, in the minor surgery, we cannot use in the minor surgery, the general anesthetic we cannot use, and in the minor surgery we prefer only the local anesthetics. And the last point is poor health patient, it is risky, general anesthetics are risky in poor health patient, and the local anesthetics, and that is safer because it acts locally and it is restricted towards the particular area of the body. Then the mechanism of action. So, in the mechanism of action there is no specific receptors has been identified to create the stage of the general anesthesia, but there are some important point that we have to discuss here, that at the clinically effective concentration, means at the effective dose, the general anesthetics increases the sensitivity of the gamma aminobutyric acid, that is the GABA receptor in the inhibitory neurotransmitter. So, it acts on the at the GABA receptors. I will discuss the mechanism of action in the next slide. So, here this is the GABA receptors, here the drugs binds at the GABA receptors. So, what is the function of the GABA? Binding of this GABA receptors, it causes chloride ion channel opening. So, due to the chloride ion channel opening, it causes hyperpolarization. So, here this chloride ion comes in, so that the negative concentration here increases. So, the increment of the negative ion concentration at this site, it causes hyperpolarization. When we are using the general anesthetics, in case of inhaled anesthetics, it binds with this GABA receptor and it increases the chloride ion channel opening. So, due to the chloride ion channel opening, the more negative ion concentration comes in. So, it will causes the hyperpolarization. Entry of this chloride ion causes hyperpolarization, making the more difficult to depolarize and therefore reduces neural excitability. So, this is the complete mechanism of action of the general anesthetics that we are using. Now, the important thing is the classification of the general anesthetics. In the previous slide, I have already discussed that the general anesthetics we have divided into two parts, that is the first one is the inhalational anesthetics, the second part is intravenous anesthetics. In this inhalational anesthetics, further we are dividing into two sections, that is the gas and the volatile liquid. In the gas, the well known example is the nitrous oxide, and in the volatile liquids, these are very important drugs used as inhalational anesthetics. It includes halothane, methoxyfluorine, enflurane, sevoflurane, isoflurane, and the last one is desflurane. So, these are the inhalational anesthetics. Now, come to the intravenous anesthetics. Again, this intravenous anesthetics divided into two parts, slower acting and the inducing agents. Basically, in the slower acting, we are using dissociative anesthesia. We can use opioid, we can use benzodiazepines. In the dissociative anesthesia, the well known example of this dissociative anesthesia is ketamine. Opioid analgesics used as the intravenous anesthetics, that we can use this fentanyl. The benzodiazepines, that is lorazepam, diazepam, midazolam, that we can use. Inducing agents, these are the inducing agents that is more common. It includes methotrexate, methohexytone, thiamyl, sodium thiopental, propofol, etomidate and dexmedetomidine. These are the inducing agents used as general anesthetics. So, in the general anesthetics, first I will discuss about the inhalational anesthetics. In the inhalational anesthetics, they are solubility in the fat, that the aisle gas partition coefficient, and the next one is solubility in the blood, that is blood gas partition coefficient. We can govern this anesthesia by using these two. So, aisle gas partition coefficient, it indicates the amount of gas that is soluble in oil phase, and it is measure of lipid solubility of the anesthetics. This is this one is very important point, the lipid soluble. So, as I have already told that this general anesthetics, they are working by crossing the blood brain barrier. So, they are more lipophilic. So, lipophilicity, that by using this aisle gas partition coefficient, it measures the anesthetic potency. Higher the lipid solubility of the general anesthetics in oil, greater than anesthetic action. So, we can measure this anesthetic action by using this aisle gas partition coefficient. Now, this is blood gas partition coefficient. It is what? That ratio of the concentration in the blood to the concentration of the gas phase. When lowers the blood gas partition coefficient, that it can faster the induction and faster the recovery of the general anesthetics. Now, the first agent used as inhalational anesthetics, it is a potent analgesic and weak general anesthetics, and this nitrous oxide have rapid onset and recovery. The third point is does not depress respiration and no muscle relaxation at this point. And the clinical use, what are the use of this nitrous oxide as inhalational anesthetics? We can use in the dental surgery, we can use in the obstetrics, post operative physiotherapy, refractory pain in the terminal illness and the maintenance of the anesthesia. Okay. Now, the next is halothane. Halothane, the important molecule in this category, that is the halothane, is the haloalkane. Why we are calling is the haloalkane? Here the involvement of this 2 carbon atom, that is the ethane, alkane 2 carbon atom, alkane of the 2 carbon atom having the 3 fluoro group at 1 carbon atom, and the second carbon atom have 1 chlorine group and 1 bromine group. So, here the IUPAC name of this halothane includes, that is the 2 bromo 1 2. So, 2 bromo 2 chloro 1 1 1 trifluoroethane, and it has a role on inhalational anesthetics, and we are also calling it as this organofluorine compound and the organochlorine compound and the organobromine compound, because this halothane have chlorine, bromine and fluorine also. So, that is why we are calling is organofluorine, organochlorine and the organobromine compound. The halothane is the potent anesthetics and the rapid induction and the recovery as the general anesthetics. And the main characteristics of this halothane is it is neither flammable nor explosive, sweet smell and the non irritant. And The third one is low incidence of the low post operative nausea and vomiting. And main important thing is the relaxes both skeletal and the uterine muscle and can be used obstetric when uterine relaxation indicated. And it can be combined with the with its pleasant odor. This makes it suitable in the children for inhalational induction. Methoxyfluorine. So, methoxyfluorine again it is made up of the 2 carbon atom, and the 1 carbon atom have this methoxy group, the fluorine and 2 fluorine and the 2 chlorine atom. So, the IUPAC name is 2,2-dichloro-1,1-difluoro-1-methoxyethane. So, methoxyfluorine is an ether in which the 2 group is attached with the central oxygen. The 2 groups attached with the central oxygen and the methyl group and the 2,2-dichloro-1,1-difluoroethyl group. So, the role is again this role is inhalational anesthetics and the non-narcotic analgesics, hepatotoxic agents also and the nephrotoxic. Again it is a organofluorine compounds and the organochlorine compound and the ether. And this methoxyfluorine is used for the surgical procedure, and it should be administered with the nitrous oxide to achieve relatively light level of the anesthesia, because the neuromuscular blocking agents given concurrently to obtain the desired degree of muscular relaxation. N-fluorine, again this N-fluorine is the fluorine contains fluorine and the 1 chlorine. So, IUPAC name is 2-chloro-1-difluoro-methoxy-1,1,2-trifluoroethane. So, again it is a organofluorine compounds and the organochlorine compound, and it is a flammable halogenated hydrocarbon. In the inhalational anesthetics, the next example is N-fluorine. So, the advantage of using this N-fluorine is it is less potent than halothane, but produces rapid induction and recovery. So, the disadvantage is the CNS excitation at twice the minimum alveolar concentration. It can induce seizure also. So, we can include this disadvantage as a side effects. Next is desflurane. So, desflurane is a organofluorine compound. There is no involvement of the chlorine and bromine. So, desflurane is a organofluorine compound and it has a role as an inhalational anesthetics, and the basic thing is it is derived from the methoxyethane. So, this is the methoxy and ethane. Methoxy and ethane. It is a derivative of methoxyethane, and this desflurane is the most commonly used volatile anesthetic agents. Less volatility, and it must be delivered using a special vaporizer. It decreases vascular resistance and perfuse all measured tissue very well. That is why we are using this is the commonly used volatile anesthetics, that is desflurane. Desflurane also it is a fluorinated compound that we know, and the exact mechanism of action is not established. That I have already told you that it acts on the GABA receptors and it produces the chloride ion channel opening. Next is sevoflurane. In this sevoflurane, it is again it is a 2-methoxy propane derivative, and it is used as the inhalational anesthetics and a platelet aggregation inhibitors and a central nervous system depressant. Sevoflurane is used for the induction and the maintenance of the general anesthesia. Isoflurane is again the next compound in this series. So, again it derives from the methoxyethane and it is a non-explosive inhalational anesthetics, relatively free from the significant side effects as we compare with the other anesthetics. Now, the synthesis of this halothane, it synthesized from the trichloroethylene. So, in the first step, the addition with addition with the HCl, and at this step dehydrohalogenation reaction, and finally, after the first intermediate, this is the second intermediate, and final step is the bromination occurs, the removal of this HBr. So, halothane is produced. Now, this is the references. Thank you so much.